Okay, so I have my TinkerCAD circuit here of the Arduino robot. I have my battery pack here, my Arduino Uno. I have the HCSR04 ultrasonic distance sensor connected here, the two DC motors here, and I have the H bridge, which is the L293D for the TinkerCAD program. Then I have an LED here, and I have the TCRT 5000, which is actually just a switch. There's no actual color sensor on TinkerCAD that I'm going to be using, so I've just decided to use a switch that I can use I can just put a digital write function in, or digital read, and I'll just read a value of 1 or 0, which is going to be black or white. So whichever way the switch is, so at the moment it's at 0, and if the switch is over here, it's going to be 1, which will be black. So at the moment it's just on white. I have the power 1 here, which is connected to the V-in of the Arduino Uno, which is actually being fed by this 6-volt battery set. That's on the top bus, and then I have that coming down into the power 1 of the H bridge, and then there's a wire there, the green wire, connected down to the power 2. I have all 4 inputs here. You can see all the inputs here, 4 input pins on each side, well, 2 on each side. My input pin here is going up to pin D4, and then the input pin over here is going to D7. Down here it's going to D2, and then we have it here going to D3. So there are my input pins, and then we have our output pins. So all 4 output pins here, and they're connected to the DC motors, each wire connected to a different output. And then we have 4 ground pins on the H bridge, and only 2 of them are connected, 1 on each side. And then we have our enable pins here, connected on each side of the H bridge, connected to D5 and D6. Next we have our LED, which is coming from a 220 ohm resistor there, going up to the cathode of the LED and coming out straight through the anode, going over to pin D12 of the Arduino. Then we have our HCSR04 ultrasonic distance sensor. I have it grounded here to the common ground. And then I have the echo pin here connected to pin D10, and then the trigger pin connected to D11. Then I have 5 volts coming from Arduino to the VCC of the HCSR04, as it needs a 5 volts signal to work properly. And then I have the TCRT 5000 here, which is connected to 3.3 volts here. So as you can see, it's 3.3 volts coming out of the Arduino there, and it's going into the bottom bus here. And I have it grounded to the common ground. Then I have it connected to pin A0 on the analog in of the Arduino. So basically what's supposed to happen here, what's going to happen is I have 2 motors here. The TCRT is going to view 0, which is going to be a white piece of paper. So it's just going to be basically the background here. It's going to be reading the background, just white. And if anything black comes along, and it reads the black, it's going to turn to digital read 1. So once it reads black, it's going to go to 1, and that means that the motors will turn into the rotating function. So it's going to be one motor will go the opposite way, which is basically going to rotate just for a few seconds, and then once it starts seeing white again, it's just going to go straight. And similar with the ultrasonic distance sensor here, I will have it set to a certain value, and if the object is within that value, the object or the robot will turn. So I'm going to go into the code now. So as you can see, I've defined all my pins. Just define them all just so I can switch from the Arduino Uno over to the Arduino Nano. And I have the variable here, duration, set as a long, and it's set as 0. Then similarly, I have CM, the variable CM, set as an integer value, and that's 0 as well. So in my void setup, I have serial.begin 9600 bits per second, and I have all my pin modes here. So I have motor A, motor A1, motor A2, and motor B1, motor B2 here. That's basically each different wire here. So motor A1 will be that wire, motor A2, motor B1, motor B2, and they're all set as outputs. Then I have pin mode trig pin and echo pin trig pin is going to be an output because it's going to be sending out a signal, and the echo pin is an input, so it's going to be taking in a signal. And I have the red LED set as an output. It's going to be outputting some light to indicate different movements, and the pin mode infrared input, which is basically this TCRT 5000 switch, and that's an input. And then I have analog right here, which sets the motor A speed and the motor B speed set to 255, and that's going to be basically 9 or 10,000 RPM up here in the motors. And then we'll go down to the loop now. So this is all the loop, this whole thing that I've highlighted here. So I have black white set as an int, an integer value, and then below that it says black white is equal to digital read infrared. So as I said, that is a digital read function, so it's going to be reading a digital value, either 1 or 0 for the TCRT 5000 down here. At the moment it's at 0, and if it switches over it's going to be at 1. Then I print my values of the color. And now here we have 3 digital write functions here, which are going to send out basically a pulse for the trig pin. So at the moment it's going to start low, and then it's going to go high, and then it's going to go low, and it's just going to repeat that. So it's going to go low, high, low, low, or low, high, low, high, low, high, low, high, low. So it's not going to send out a signal here, then it's going to send out a signal when it's high, then it's going to stop sending out a signal, so it's going to be pulsing. And then we have duration here. We already indicated this up here, so it's a long value. So the duration is pulse in echo pin high. So the pulse in function is basically going to read the value when the echo pin receives. So it's going to read the echo pin value, and that's going to be set as high. So it's going to be constantly reading the value that's returning back from the trig pin or the object. And then we have the duration in the centimeter equation here, which is duration multiplied by 0.0343 divided by 2. And that's going to give us this centimeters in distance. And now we have a if statement here, so it's going to be if black white is equal to 1, and then we have this logical OR here, the 2 straight lines here. That means OR, so it's going to be if black white equals 1 or centimeters is smaller than 30 centimeters, then rotate. And then if else, so if that's not true, just drive forward. So basically, if this TCRT 5000 reads black, it's going to spin. If not, it's just going to go straight forward. And also, if this ultrasonic distance sensor reads below 30 centimeters, then spin. Otherwise, go forward. And then simply down here, we just have our voids for the forward and rotate. That's just to simplify our loop code. In the forward here, we have motor A1, motor A2, motor B1, motor B2. Only one motor A wire is high, so that doesn't cancel it out, so it's always going to have it moving in a certain direction. And the same thing with B. So at the moment it's just going to be going forward. And then we have the red LED set as low, so there's not going to be any light output from the LED. And then in rotate, it's the same thing, just that the motors are going to be rotating this time. And the red LED is high, so it's going to be letting out a light when it's rotating, just to indicate that's rotating. And then it's going to delay this rotation void for 500 milliseconds. So we'll view how this is working, and I'll get the serial monitor up now. So at the moment, the TCRT 5000 is reading 0, as you can see, and the ultrasonic distance sensor is reading above 30 centimeters. So the motors are just going minus 10,000, minus 10,000, so they're going the same speed, or same direction. Now, if I go below 30 centimeters, if it sees an object below 30 centimeters, LED comes on, and the bottom DC motor here will go to positive 10,000 RPM. So it's going to be spinning the opposite direction as the minus 10,000. And then we can just put that back. So just imagine that's after rotating, and now the object isn't in its way anymore, so it's going to go straight again. Both of the motors are at minus 10,000 again. Then if it sees the edge of the arena, which is going to be black tape, it's going to see 1, LED will come on, and then the DC motor will go to 10,000 RPM. And as you can see there, it says color is equal to 1. And then same thing again, once it goes back to 0, LED will turn off, and the motors will be back to 10,000.